So hypothesis test for population proportion. First, we check the normality. NP is larger than equals to 5. N times 1 minus P is larger than equals to 5. Then we state the null hypothesis, alternative hypothesis. When it comes to null hypothesis is a statement including equality, larger than or equal to, less than or equal to. Alternative hypothesis, which is the opposite, the complement of your null hypothesis, includes not equal to, it's not, less than, larger than. Then we go to step 3 to specify the level of significance, alpha. 4, we calculate the critical value depending on what is the behavior of your alternative hypothesis. We specify the rejection region. We find the test statistic, which for population proportion follows the formula Z equals to P hat minus P divided by square root of P times Q, or 1 minus P times square root of N. Then we check if this number is inside the rejection region or not. If Z is in the rejection region, then we reject the null hypothesis. Otherwise, the terminology that we use is we fail to reject the null hypothesis. Let's take a look at one example. A researcher claims that less than 40% of US cell phone owners use their phone for most of their online browsing. What are we going to do as a statistician? We're going to take a random sample. This random sample has 100 adults in it. Out of those 100 adults, 31 of them, which we form 31%, say that they use their phone for online browsing. Question says, at 1% level of significance, is there enough evidence to support the claim? Well, we are the statistician. We know how to deal with a hypothesis testing. We need to follow the steps. Our very first step is to check to see if N times P is larger than or equals to 5. So we need to find N, we need to find P. What is N? N is the sample size. N is the sample size. What is my sample size here? Well, the sample size is we select 100 adults. This is 100. What is P? P is the population proportion. Read the question carefully. Population proportion is given to us in the claim. This is the claim, says that, hey, 40% of US cell phone owners. This is a claim. We don't know if it's true or not, but this is the claim. US cell phone owners, 40% of them. So population proportion is given to us as 40%. We need to check normality. What is N times P? What is N times 1 minus P? Are these two numbers larger than equals to 5? So 100 times 40%, which is 40, of course larger than equals to 5. And N, 100 times 1 minus 40%, or 60%. 60 is larger than equals to 5. So the normality is met. We are allowed to go to the next step, constructing the null hypothesis, alternative hypothesis. Read the question. It says less than. When we are working with less than, it means that it is less than 40% of population proportion. It says P is less than 40%. This is the claim that we have. What is this? Is this the null hypothesis or is this the alternative hypothesis? So the question says, well, P is less than 40%. Remember that your alternative hypothesis has no equality. So it says the alternative hypothesis says the population proportion is less than 40%. So what is the opposite of less than? The opposite of less than is larger than or equal to. It says the population is larger than or equal to 40%. Or in another word, the population proportion is at most. Am I right? Is it at most or at least? P is larger than or equal to. Is it at most or at least? Half of the class said at most, the other half said at least. The minimum value is 40%. It might be 41%, 42%, 43%, 50%, 55%, 60%. So it is at least, not at most. Do not make that mistake. At least 40%. So alternative hypothesis is given in the question. It says less than, and P larger than or equal to, which is at least 40%. What is the level of significance? Well, the level of significance is given to us as 1%. 0.01. Very good. What's the next step? Our next step is to find the critical value. What is the critical value for 1% associated to P less than 40%? Here you have a left-tailed graph because P is less than. So our normal distribution says we have a left-tailed graph. Okay, for this left-tailed graph, for this left-tailed graph, 1% is on the left-hand side. This is just 1%. So let us use our calculator. Turn on the calculator, go to second, vars, find inverse norm. The area is just 1%, mu is 0, standard deviation is 1, and let us find the z. The z is negative 2.33, but the critical value that we're going to use must be representing the area to the left-hand side. Very good. In the next step, we're going to find that the test statistic, the rejection region, and the critical values are given to us. And here it's on the left-hand side. If you have a right-tailed graph, it must be positive. So for now, just keep these as they are. What is p hat? Well, p hat, let us find p hat. P hat says, hey, I have 31%. 31%. So this is my p hat. P hat is 31%. Let's plug those in and calculate this number here. Very good. So Z is equal to P hat, which is 31%, minus P, which is 40%, divided by square root of P times 1 minus P. P 40%, 1 minus 40%, times square root of N. N is 100. By using our calculator, the number that we get is approximately negative 1.84. This is my test statistic. Is my test statistic inside the rejection region? Well, this is my zero. This is my mean, 0. Negative 1.84 is not in the rejection region. This number, negative 1.84, this number is roughly here, which is outside. It's outside the rejection region. It is outside. So what's the meaning of that? It means that we fail to reject the null hypothesis. What's the meaning of that? It means that at 1% level of significance, at 1% level of significance, there is not enough evidence to support the claim. So we failed to reject the null hypothesis. We failed to reject this. Unofficially, we are somehow with this information accepting this. We failed to reject it. So it means that we cannot support the alternative hypothesis. So when it comes to hypothesis testing for population proportion, we have to follow some important steps. First, we need to check the normality. We need to find the null and alternative hypothesis, identify the level of significance, find the critical value, identify the rejection region, find your test statistic, and check to see if that test statistics is inside or outside the rejection region. If it's inside the rejection region, we reject the null hypothesis. If not, we fail to reject the null hypothesis. Let's go over another example. Very good.